This is a lesson on solving systems using substitution. Now you can see I have two equations in slope-intercept form, and they're not equations that I'd like to graph just because the y-intercepts are pretty big and the slopes are pretty steep. So I know that the slopes are different, so I know that they will intersect. I know that y is equal to this, so what I'm going to do is I'm going to actually just substitute all of this equation in for y in the other equation. So instead of y here, I'm going to plug in 8x minus 13, and the other side of the equation is just going to stay 5x minus 17. And what that does for us is it gets rid of all of the y's temporarily. Now we can try to solve this equation. So if I subtract 5x from both sides, I get 3x on this side, and the x's go away. And at the same time, I'm going to add 13 to both sides, and I get negative 4. If I divide both sides by 3, I have x equals negative 4/3. So that is the x value where the lines are the same. So if I now use that information, I know that if I plug in 4/3 into each equation, I will get the same number. I'm going to do it for both equations. So we have y equals 8 times negative 4/3 minus 13. So we have nothing canceling, nothing reducing here. So I'm going to have negative 32 over 3. And then 13, if I multiplied the denominator, which is 1, by 3, I'm going to multiply the numerator by 3, and I get 39, which gives me negative 71 over 3. And that's what I'm solving, and I'm getting for y. I'm going to do the same process with the other equation. Y equals 5 times my x minus 17. It's very similar. Y equals, again, nothing's reducing. I get negative 20 over 3. I subtract. I need a common denominator. I multiply the denominator 1 by 3. So I multiply the 17 by 3. And I get negative 71 over 3 again. So that just confirms that that is the y value. It's not, you're not using the y value more than once. That is the y value. So then I'm going to write my point as x comma y. Do a nice dark black marker. Negative 4/3, comma, negative 71/3. That is my point of intersection. Not a fun point, but you got to feel pretty good about getting that one. One more. 2x minus 5y equals, I'll come up with the number in a second, y equals 2x plus, let's say, 2. Let's see. Let's go with negative 26. So here's a different scenario. We have a slightly different substitution problem where we have a y value here, and it is equal to 2x plus 2. Now the position of the y value here is in the equation, kind of buried. So what I'm going to do is write out this whole equation, except wherever there's a y, I'm going to put parentheses. And all of this other equation is going to go into that parentheses, replacing, substituting for the y value. Everything else stays the same. So we have this nice equation. We only have x's in it, so we can solve it. So let's try it. 2x, distribute. The negative goes with it. So negative 5 times 2x is negative 10x. And again, negative 5 times positive 2 is negative 10 equals 26. We're trying to solve for x. So what if we combine these two? 2x minus 10x is a negative 8x. I'm going to add 10 to both sides. That's a negative 26 over there. I lost my negative, so that will then give me a negative 16. And if I divide by negative 8, I get x equals 2. I like x equals 2. Now I'm going to plug them in to each of these equations. I'm going to start with the bottom one, because I can almost do that one in my head. It's 2 times 2 plus 2, 4 plus 2. I should be getting a y value of 6. So I think the point is 2 comma 6. So now, there's another way you can do this. You can actually plug in 2, 6 here and see if it comes true. So let's try that out. Let's go 2 times 2 minus 5 times 6, and the result should be a negative 26. Well, that's 4. That's 30. And if I subtract 4 minus 30, I get my negative 26, which is true, which means 2, 6 is the solution. So there's another example of substitution.